Let's try problem 12.40. 30 grams of copper pellets are moved from a 300 degrees Celsius oven and immediately dropped into 100 milliliters of water at 20 degrees Celsius in an insulated cup. What will the new water temperature be? Okay, so this is just going to be a heat problem, right? The ones that we've been working with. So Q is going to be equal to the mass times the specific heat times the change in temperature. Do capital T, actually. And so the first thing we need to know is the specific heat of both the water and the copper pellets. So if you look over in table 12.4, you will find that the specific heat of copper, call it C sub C, is going to be equal to 385 joules per kilogram times Kelvin. And the specific heat for water, C sub W, is equal to 4,190 joules per kilogram Kelvin. Okay, so we're also told that this is an isolated system, right? Because we're told that it's insulated. So all of the heat given off by the copper pellet when it's dropped in the water is going to be absorbed by the water. And so another way to say this is that energy is conserved, or that the heat from the water plus the heat from the copper is going to be equal to 0. And so all that means is that, right, the water is going to absorb the heat from the copper, and so the copper is going to give off heat, making this negative, and the water is going to absorb heat, making it positive. And so another way to write this is just the mass of the water times the specific heat of the water times delta T, capital T, plus the mass of the copper times the specific heat of the copper times delta T. This is going to be equal to 0. Okay, so now what are these delta T's? We know that this delta T, right, is just going to be the final temperature minus the initial temperature. So T sub F minus T sub I. Call it T sub I of the water. And then this delta T is just going to be the T sub F final temperature minus the initial temperature of the copper. But something to notice here is that these final temperatures, this one and this one, both have to be the same, right? Because they're going to come into equilibrium with each other. And so this final temperature is what we're trying to solve for. So let's rewrite that let's rewrite this equation with that filled in. So M sub W, C sub W times the final temperature minus the initial temperature of the water, I'm just going to call it T sub W, plus the mass of the copper times the specific heat of the copper times the final temperature minus the initial temperature of the copper. And this is going to be equal to 0. And so if you notice right here, this Q sub C is going to be negative, right? Because the final temperature is definitely going to be less than 300 C, which is the initial temperature. Okay, so now our goal is to solve for T sub F. And so what I'm going to do is multiply through this M sub W, C sub W to this first part. I'm just going to multiply out this first part. So M sub W, C sub W times TF minus M sub W, C sub W, TW. Okay, so that's this multiplied out. So now let's multiply out the second part. So plus M sub C, C sub C, T final, minus M sub C, C sub C, times T sub C. And this is all going to be still equal to 0. So now why I did that is so that way I can factor out this T sub F here. So I'm trying to factor out this T sub F, and I'm trying to factor out this T sub F over here. And so if I rearrange this equation, W, C sub W, TF, plus m sub c, c sub c, Tf minus m sub w, c sub w, Tw minus m sub c, c sub c, T sub c. This is going to be equal to 0. Now I can factor out a T sub f from both these first two equations over here, right? And then I can add this and this to the other side. And then I can isolate my T sub f. So let's go ahead and do that right now. Ooh, wrong brush. So let me just clear out some room over here. Okay. So now I'm just going to factor out that T sub f. T sub f times mass of the water, heat of the water, plus mass of the copper, sub heat of the copper. It's going to be equal to mass of the water, sub heat of the water, right? Because I'm adding this to the other side of the equation. T of the water minus mass of the copper, sub heat of the copper, times temperature of the copper. Okay, so now all I have to do is just divide both sides by this over here, and I finally isolate my T sub f. Equal to m sub w, cw, tw minus mc, cc, tc all over mw, cw plus mc, c sub c. And so we know all this, right? We know the mass of the water, we know the specific heat of the water, we know the temperature, the initial temperature of the water, we know the mass of the copper, the specific heat of the copper, temperature of the copper. And so we know this whole side. And it turns out when you plug all those numbers in, what comes out is 28 degrees Celsius. And so the water is going to increase to 28 degrees C, and the copper pellets are going to decrease to 28 degrees C. And so that's problem 12.40.